Section 1.6, graphical transformation.
Okay, now this is the root of everything we're going to do this year.
Okay. We've been saying that on like every section.
For real.
For real though. Okay, we're going to use all the stuff from 1.2 in a way. Like 1.2 is super
But this
important.
stuff, translations of graphs.
It's a big deal because guess what? If you know your 12 basic functions from 1.3 and you understand the way these transformation rules work, you can graph anything you want without ever having to pick up your calculator.
Double stamp C's to infinity and beyond.
Okay, so that means you agree.
I totally 100% agree.
Okay, awesome. So here's some different vocabulary words real quick. A
Okay.
rigid transformation means you don't change the size and shape of the graph, you just move it. You just like move it.
I'm rigidly moving out of the picture.
Right, but
rigidly moving in, but I
yeah.
don't change my position at all.
No,
I just am tilted.
size and shape. You change your position,
size and shape, yeah.
not size and shape.
But I'm still squeezed in together, fist right here. My shape hasn't changed.
Right. So
Okay.
that's
My
like
shoulders were hurting.
yeah, vertical and horizontal shifts and reflections. Could you reflect across the x-axis for us real quick?
I need a split pick for that. If I had split pick, I could do it.
Okay.
All right.
Non-rigid transformations do the opposite then. They actually change the size or shape of a graph so that, you know, like if he could just get like bigger, like all of a sudden.
Like if you look
in
at my
Harry
head
Potter,
now, and
Aunt
you look at my
Marge,
head now, I'm bigger.
That was a stretch. Yeah.
That was a stretch.
Yeah. Okay, so vertically and horizontally, we can talk about stretches or shrinks.
Or the bus on Harry Potter. Was that where you're headed?
No, I was talking about Aunt Marge, when Aunt Marge blows up.
Oh, yeah, yeah. But
she was
you've also
both
got,
vertically and horizontally stretched.
she was. Or
The night bus.
The night bus.
Shrinks.
When it shrinks to go in between the cars.
Yes, lots of Harry Potter references today. All right,
Yes.
Translations. You can translate vertically, which is up and down. You can translate horizontally, which is left and right. And the important thing to know is every single time you do this, these rules will happen. So every single time. So if your number, okay, we have this f of x thing here. So f of x can be things like x squared.
Oh, that's x squared. That's
okay?
the basic function right there. That's what f of x is
F
our
of
basic
x
function.
could be absolute value of x.
Yep. Oh, hey.
F of x could be
sine x.
sine of x. Okay, this is what we're talking about when we say f of x. There's going to be some kind of actual function there. And so whenever we talk about being outside of our function, we're talking about there's going to be a number out here somewhere. You know? That if, you, like for absolute values, there's an obvious inside and outside, I think. Inside, the absolute values is inside.
Right.
Outside is outside.
Right.
For some of these other ones, you're looking for parentheses.
Right. Like on x squared, there would be a parenthesis.
If you're inside.
If you're inside.
But if there's no parentheses, you're outside.
Same thing for the sine.
Yeah,
so it
this
just
is
depends.
outside.
You'll start to catch that.
That kind of thing, yeah.
Right.
So if we're adding something outside of our function, we go up because we're directly affecting our y values.
Right. Because
Okay.
f of x is equal to y.
Yes.
So if we're saying f of x equals x squared plus 3,
Yeah,
then that
we're
means
taking-
the y is affected plus 3.
That's right. If we subtract c, the opposite happens, and we
Right.
shift down however many
Exactamundo.
the c units are. Horizontal translations, what you have to remember is anytime we're inside of a function, we are in the super secret opposite society.
Every single time, the
Okay.
SSOS.
Okay? If you can remember that, that means that anything that happens inside of your function, the opposite is going to happen than what you think. So if I subtract c on the inside,
I'm actually going to move in a positive direction
Which
on
is
the
to
x-axis.
the right.
That is correct.
Okay? If it's a plus c on the inside,
We're moving in the opposite direction.
which is left c units.
That's
Okay?
correct.
So when we're outside, we're not a part of the society, but when we're inside, we're a part.
Super secret.
The super secret opposite, because we're going to change it to the
That's right,
opposite
that's right.
society. Okay, so
Thank you,
let's
Mrs.
do
Golden, for that reference,
Yeah,
by the way. We'll
yes.
give credit where credit is due,
sometimes.
usually.
Okay, so let's do an example.
Hey,
of
let's
this.
do it. Hey, look, that looks like absolute value
Of x.
of x. Yes,
Okay,
just of x.
y equals the absolute value of x. So our parent function is the absolute value function.
Right.
And we're trying to describe how the graph of this can be transformed to the graph of the given equation. So what matters...
It looks to me like that -4 part is not inside the
Right.
absolute value.
Right, this is outside, which means it's affecting our up and down. Since it's negative, it's legit pulling us down
Right,
4.
right.
So we would write that we are shifting down 4. or shift down 4 or something to that effect. And
4
you don't,
units.
You don't have to put units. I mean, you can.
We didn't put units here, but it would be some sort of unit typically.
You could put units or you could not. So.
Okay, all right, so quick pause. So let's take a look at the graph then.
Okay, without using our calculator.
Yeah. Oh, okay. And graph the parent function first.
Okay, so in pink here, I know the absolute value of x.
I do too.
It's a v.
Yes.
With like, if you imagine slopes of 1 going both directions.
No, not slopes of 1 going both directions. A slope of negative 1 and a slope of 1.
My apologies.
Get your vocab correct.
So
we got that mistake on film.
Yeah.
I'm gonna ride that one.
Now, all we're doing is taking this parent function and moving it down 4. So
4 units.
Uno,
1,
dos,
2, 3,
tres,
4.
cuatro, and then otherwise it should look the same. Like we should have like a parallel line situation going on, which I am freehanding, so I mean it looks okay.
I mean it's not bad.
Okay, but that's all that happened. We just took what we had and we moved it down 4.
Took all the y coordinates down 4.
Okay,
all right.
So let's do the next one.
Okay, notice now on this one, like Mrs. Stevenson said on our opening slide, we've got that 2 on the inside of the absolute value, and it is obviously on the inside.
It is in the inside, right. It's inside of our absolute value bar. So this is a part of the super secret opposite society. So instead of +2 taking us to the right 2, it actually takes us to the left 2.
Left.
To the left. To the left. Everybody go to the left. Left
Hey, isn't
2.
there a song?
There is a song about that. Shift left 2.
No, that's not the name of the song.
No, that's not. You're
Okay.
right. And you don't have to write units, but if you want to, you can. So let's graph. Let's think about what the graph looks like then.
So we're going to, again, start with the absolute value graph, which is the V.
A V for victory.
That's right. V for vociferous.
What does that have to do with
I don't know.
Okay.
Now, that whole
Left
thing
2.
is going to go not right 2 because it says +2, but actually the opposite of that, which is left 2, and then it's an identical replication of the graph.
You're just picking it up and moving it.
Boom.
Okay.